Hi everyone, welcome to my YouTube channel Study with Soumya. I hope you all are well and safe. First of all, if you are new to this channel, make sure to subscribe this channel if you haven't subscribed till now. What I have observed that many of the students watching the videos are not subscribing the channel. Make sure to subscribe the channel, guys. It is going to be very helpful for you, and also it will motivate me as well to make some important and useful stuff for all of you. So make sure to subscribe the channel, and when subscribing the channel, don't forget to turn on the bell icon. Well, in the previous video we discussed about the basics of linked list, that what is basically a linked list is and how it is different than that of array. Why do we need a linked list? Right now in this video we'll be discussing that how to create a linked list, how we can create a linked list, and how we can traverse through the linked list, right? So first of all, in the previous video itself, I have told you that how basically we logically represent a linked list. Let me draw here as well. So just a minute. Okay. So this is how we logically represent our linked list. And here is a pointer, that is head pointer, that is pointer to a node itself, right? So it is pointing to our first node. Now I already told you that a node consists of two fields. The first one is data field and another one is the address field. Well, as you know that in case of linked list there is no concept of contiguous memory allocation, which was kind of problematic in case of array, because maybe a possibility, maybe a scenario that we are not able to continuously, we are not able to get the memory in a contiguous manner, because maybe some another data is stored at that particular memory allocation. So in that case you cannot occupy that memory in case of array, because array follows the concept of contiguous memory allocation. But this is not a hurdle in case of linked list, because it does not follow that particular concept. Then how do we access the data? Okay, so that's why we have this extra field here in case of linked list, that is address field. So if suppose I want to access this particular node, so I have the address of this node along with me. So no matter wherever this node is stored in the memory, as if I'm having the address, I'll be able to reach that. You can think about this like this. Suppose, okay, so this and this, okay, let's give some name, Ram and Shyam. Okay, Ram and Shyam are friends. Now, Ram is not aware that where Shyam lives. Okay, Ram is not aware of this fact. Now, Shyam did what? Shyam want to invite Ram to his home for some party and so that's why Shyam gave his address to Ram. Now, as if Ram has the address, it's very easy for him to reach his house. Okay, so that is the concept that we do have in case of linked list, that we have the address. So no matter where that particular node is allocated, it's present, you can get this particular node by using that particular address. It's that simple, right? So let's suppose the address of this node is 300. So we have this address 300 with us in the previous node itself. And let's suppose there's some data 30, 60, 90. The address of for this particular node, let's suppose we are taking it as it is 100, and for this one we are taking it as 400. So as if this is pointing to this particular node, so it is having the address of this particular node, and the last node will be pointing to null, right? So remember that last node will be pointing to null because it's having no data, or you can just simply represent it as by 0. Okay, so it's having no data. Now I am making this symbol just to represent you. It's not like a pointer is having some sort of hands that it will be pointing to this, right? Pointer is able to access that particular node by using its address itself. Now, how we are going to create a node? This is the first question. Well, moving further in this video, what is the prerequisite? As if I told you in the previous video itself, that one more advantage that linked list has over array is that here you don't have to mention the size of the linked list at the compile time, as we do in case of normal arrays, right? I'm not talking about dynamic array, but in case of normal arrays we have to mention the size at the compile time itself. But as if linked list follow the concept of DMA, that is dynamic memory allocation, where memory is allocated at what? At heap segment. So here you don't have to mention the size of the linked list at the compile time, because at the runtime itself memory can be provided to you. Okay, so for this we'll be using malloc function here. So I'm hoping, I'm considering that you are aware of this dynamic memory allocation and all such stuff. Okay, so now let's see that how we are going to create a node. Okay, so first of all, as you can see, a node consists of two types of data, as if I just shown you. So here, as of now, we are having this integer data. So what we'll be using here, what data type we'll be using here, we'll be using structure here. So you have to use the keyword struct, give some node, that is, let it be node itself. And now your node consists of data that is of integer type, and we have a pointer of type struct node pointer, and let's name it as next. So our pointer name is next, as if it is pointing to the next node itself. Okay, so this is our node consisting of these two data. Now if you want to create a node, then what you have to do, if you want to allocate some, as of now, see, as of now, no memory has been allocated. If you have created a structure node consisting of these two particular data, as of now, no memory has been allocated. So for this, we'll be using malloc function for allocating the memory. So first of all, I want to create a head node or first node. You can name it anything. So for head node, now you must be knowing that malloc function will be doing what? Malloc function will be dynamically allocating a single large block of memory with the given size, that whatever size you are going to mention. Also, it returns a pointer of type void. So according to your data, you can just typecast into a pointer of your own choice. Okay, that you must be aware of. So here, first of all, we'll be doing the typecasting, that our pointer is of type struct node. Now malloc, now you have to mention the size that you want to occupy, size of struct node. Okay, so here we have created our first node, that is head node. Now you have to provide some values. Okay, so for head, I want to access this. How can I access? We can use arrow operator here. So this is what head is what? This is a struct pointer. Right, so make sure to be aware of this. Don't get confused that it is a struct pointer. Now by using this, I want to access this data. So how can I access? By using this arrow operator. So I'll be doing head arrow data. I want to store 53, let's suppose here. Now, and to this pointer next, what I want to store? Here I want to store the address of my next node. Let's suppose to this node I want to get this node now. So I'll be storing head of next equal to, let's give some name to it, like it's dummy next equal to dummy. Okay, so you can see that this is how I created my first node consisting of this data, and the next pointer is pointing to another node, that is dummy. Okay, so now you must have got the proper understanding that how basically we can create a node in the linked list. Let's talk about traversal as well, although I'll be writing the code, but as if we are discussing, so let's talk about traversal as well. Well, traversal part is very easy, so let's understand about this as well. Okay, so let's suppose if you want to traverse through this linked list, how you can do so? So simply, if you have this head pointer that is pointing to your first node. Okay, so what you can do something like, okay, you have to print all these data till the time head is not equal to null. So we'll be printing that data, and you can see when this head is going to be equal to null, I have to stop right there. So we can put a condition that while head not equal to null, what I have to do, I have to simply traverse through this complete linked list. So I have to print 30. So how I can print 30? I'll be doing simply like this, that printf %d head arrow data. Okay, now I want to move to this particular node. Okay, as if I already printed 30, now I want to move to this particular node to print 60. So what I have to do, simply I have to update the value of head as head arrow next. This is what I have to do, and simply you will be getting all the values that are present, all the data values that are present in your linked list, right? So I hope that you must have understood both the creation and the traversal part. So let's have a look on the code in the C language so that you can get a proper understanding. So let's move to the compiler. Okay, so here we are. First of all, I need a struct node. So that consists of integer data. It's not like you can take only integer data according to your requirement. If your data is of float type, so you can mention float here according to your needs. If it is of character type, so you can take character here. It's according to your need only. Okay, so struct node next. Okay, so now let's move to this main function. Now struct node, I want pointer head. Okay, let's take another pointer dummy, another pointer dummy1, right? So first of all, for a head pointer, what I'll be doing, so first of all I want to create a head node. So for this I'll be doing head equal to, so let's do the typecasting, struct node pointer malloc size of struct node, right? Now for these, okay, so for I want to create a dummy node as well, dummy1 node as well, and dummy2 node as well, right? So for this I'll be doing dummy equal to, so it is dummy1, and next one, this is dummy2. Okay, so you can see here I have created 4 nodes. Now what I'll be doing, so first of all, to my head node, what I want that the data is stored in head should be, let's take it as 10, and to the next I want dummy, right? So dummy I have taken. Now I'll be doing, okay, so now dummy, to this dummy node, what data I want to store, so dummy arrow data, let it be 20, arrow next I want dummy1. Cool. Now for this dummy1 data I want 30, dummy arrow next I'll be taking dummy2. Fine. Okay, so for dummy2 I'll be taking data as data 40. Allow, I am considering this as my last node, so last node will be pointing to what? Null. So let's do this. Next equal to null. Okay, so that is done. Let's run this one so that we can make sure that, okay, everything is working fine. Okay, so as of now everything is fine, right? So now what we have to do, we have created the nodes, we have linked the nodes. Now I want to print them. I want to print them to see that how basically our link is looking like, the data is printing well or not. So for this we'll be defining a function for printing linked list. So let's name it as print. And now how you can print linked list, if you have this starting pointer or this head pointer, so I'll be basically passing that head pointer to a function for printing all the data that is present to our linked list, right? And let me define this function. So as if it is not returning anything, so that will be of void type. Now it's storing head, that is of type struct node pointer temp, is referencing to the data to which our head is pointing to, right? So now what I'll be doing, that while temp not equal to null, what basically I have to do, that simply printf %d and temp arrow data Now I want to move to the next node. So for this, I'll be updating the value of temp as. So temp equal to temp arrow next, right? So this much is the code that you have to write for printing the data. So let's run our code once. So you can see we are getting 10, 20, 30, 40, right? So if you want to create one more node, so this also we can do. Let's take another one, dummy 3, okay, and let's allocate memory as well for this. So dummy 3, and here just instead of null you can mention dummy 3, and for dummy 3 data, let's take it as 50. And now as if this is our last node, so I'll be doing, okay, that its next should be equal to what? It next should be equal to null. Let's run this again. So you can see now we are getting 10, 20, 30, 40, 50, right? So this is working fine. So I hope that you must have understood the creation and the traversal of the linked list. In the next video, we'll be discussing about insertion in the linked list, that how you can insert data at a particular position at the beginning, at the end, or at a particular position between the nodes. Right, so make sure to subscribe this channel so that you can stay tuned for the upcoming videos. Also, don't forget to share and subscribe this channel. Thank you for watching this video. Bye bye. Keep learning.